Alright, welcome back to another explain video about HSC questions. Today we're going to be doing the 2020 Independent Physics paper, question 23, worth 3 marks. Now, it reads as the total energy of a satellite is equal to the sum of the gravitational potential and orbital kinetic energy. So what we have here is the energy total is equal to GPE plus kinetic energy. And that kinetic energy is when you launch the object into space and it starts orbiting around the planet. Now, it says, however, the work to put the satellite into orbit is less than this. So the thing that we're seeing right now, what we should see is total energy, gravitational potential plus that. But what we're seeing is if we're looking at the total energy, it does not equal to gravitational potential plus the work done. So why is that the case? Let's get into defining the difference, okay? So the main thing that's different between the two is the distance. So distance of calculation is different between gravitational potential and work done. Okay, why is that the case? So by definition, what we know is gravitational potential energy is defined as negative capital G m little m over r. Now r is the distance from the center of the object. Okay, so that calculates from the center. However, the work done to launch satellite into space or into orbit calculates from the surface of the planet or surface of the planet instead of being from the center. If you accounted the work to move from the center to the orbit, it would equal to total energy. Therefore, law of conservation has not been contravened. Okay, now in case this might confuse a couple of people, let me just draw this out as a diagram to show you what's happening. So, and you can use a diagram if you want when answering this question. So this is our planet. This is the center of the planet. From this point up to here, which is our satellite, this is the distance r. At this point here, this is the gravitational potential energy. When you're launching something into space, the work done is actually starting from here. So this is the ground zero point when we're talking about work. This is the ground zero point when we're talking about, Well, this is the measurement we're starting from when we're talking about gravitational potential. So for the work done, it's from the surface to that distance. So you can see that radius there from here is not equal to the displacement of the work from the surface of the planet to the top there. So that's why they don't match up. Okay, but if we did add in our calculations, if we considered the work it took to get from this center of the planet to the surface, then to the orbit, that would match up to the total energy. So that's why launching it from the surface up, even though the work done does not and the gravitational potential does not equal the total energy of the system, you know, it hasn't actually been, the conservation of energy has not been contravened. For that reason that we didn't actually consider this distance originally. That's how you do the question.